angles in the coordinate plane notes. So in these notes, we're going to talk about how to convert from radian to degree and then from degree to radians. So to go from degrees to radians, we're going to multiply by pi over 180. And then to go from radians to degrees, we're going to multiply by 180 divided by pi. So let's look at the first example here. So we have 60 degrees, and remember, in order to go from degrees to radians, we're going to multiply by pi over 180. So I'm going to put this value over 1 and multiply by pi over 180. And then I'm going to look at the diagonal, okay, and see if I can reduce anything. Well, 60 can go into 180 and 60. And so if we do 60 divided by 60, that's 1, and 180 divided by 60, that's 3. So that means we're left with 1 times pi, which is pi, over 1 times 3, which is 3. So our answer is pi thirds. Okay. Next one, we're going to put this over 1 and multiply by pi over 180. Okay. And then we're going to see what can go into both of these. Well, we have 150 and 180, okay? We know that 30 can go into both of them, and that means we're left with 5 and 6. So this is 5 pi over 6, okay? Next one, we have negative 27 degrees. I'm going to put it over 1, and then I'm going to multiply by pi over 180. And then I'm going to look at the diagonal and see where I can cancel anything out. Well, both of these are divisible by 9. So negative 27 divided by 9 is negative 3. And 180 divided by 9 is 20. So if I multiply across, this is negative 3 pi divided by 20, which is our answer. Okay. Now let's look at example 2 and notice that we now have radians that we need to convert to degrees. So in order to do this, we're going to multiply by 180 over pi, and we're still looking at the diagonal. So notice in this diagonal, the pi's cancel out. And then in the other diagonal, we can divide both sides by 3. And, sorry, not 3, 6. 6 can go into both of them. So this is, we're left with 1, and this one we're left with 30. So this gives us 1 times 30, which is 30, over 1 times 1, which is 1. So this is 30 degrees. Typically, these are whole numbers. Okay, next one, we're going to multiply by 180 over pi. Looking at the diagonal, I notice that these pi's cancel out. And then looking at the other diagonal, if I divide both of them by 3, I'm left with 1. And then 180 divided by 3 is 60. So then I do 10 times 60, which is 600, over 1 times 1, which is 1. So this is 600 degrees. Okay. Now I have negative 3 pi over 4, so I'm going to multiply it by 180 over pi to turn it into degrees. Looking at the diagonal, the pi's cancel out. And then looking at the other diagonal, we know that 4 goes into 180 45 times. And then we just multiply across. So negative 3 times 45 gives us negative 135 degrees. Okay. So that's the first part of the notes. The next part of the notes is just some definitions here. So first we're going to look at this part where it says angles in standard position. Okay. It says an angle in standard position is if the vertex is at 0, 0 and the initial side is on the positive x-axis. So it's talking about this side right here. Notice that this side is the positive side of the x-axis. If it starts here, then this is standard position. Okay. Then we have a positive angle, and that positive angle starts right here at the standard position at the positive side of the x-axis, and it goes counterclockwise. Okay, remember counterclockwise means it's going this way. Okay, and when it goes counterclockwise, we get a positive theta value, which means we get a positive angle. And then the last one here is talking about a negative angle. So we're still starting from standard position, but now we're going clockwise, which means we're going in this direction. And notice that we're going under the x-axis when we start. So our theta value is going to be negative, so we have a negative angle. Okay. Next part is a reference angle. So a reference angle is a positive acute angle measured from the x-axis to the angle's terminal side. Acute angle is an angle that is less than 90 degrees. So let's look at the first example here. Okay, so in this first example, notice that we have our initial side here, okay? And then we're looking at the angle 150 degrees. Well, notice this angle goes counterclockwise, so it's starting at 0 and it's going all the way here to the terminal side. This entire area here is 150 degrees, okay? So what we're trying to find is this theta value that is between the x-axis and the terminal side. Well, we also know that half a circle is 180 degrees. So if we're trying to find the theta angle, we just do 180 minus 150, and that gives us 30 degrees. Okay. Now let's look at the second example. Okay, so again, starting right here at the initial side, my angle is positive, so I know I'm going counterclockwise. So that means I'm going all the way around here until I hit my terminal angle. And this entire shaded region is 225 degrees. Okay. And what I need to try to find is I need to try to find the angle that is between the y-axis and the terminal side. Okay. So what we're going to do is we're going to take this 270 right here, okay, and we're going to subtract our 225. So 270 minus 225, and this is going to give us 45 degrees, which means that this angle right here is 45 degrees. Okay. Now let's look at this one right here. So notice that it gives us 7 pi fourths. So before we can graph what this angle is, we're going to have to turn it into degrees. So in order to do that, I'm going to multiply by 180 over pi, and I'm going to look at the diagonals. Well, on the first diagonal, the pi's cancel out, and on the second diagonal, we know that 4 goes into 180 45 times. So that means I have 7 times 45, which is 315 degrees. Okay, it's positive, which means it's going counterclockwise. Okay, so it's starting at our initial starting point is the positive side of the x-axis, and it's going all the way around until it hits the terminal side right here, which means this whole shaded area is 315 degrees. Well, we know that an entire circle is 360 degrees. So in order to find this theta value here that's separating the terminal side and the initial side, we just do 360 minus 315, and that is going to give us 45 degrees. Okay. However, this is not our answer because our original thing was in radians. So I need to convert this into radians by putting this over 1 and multiplying it by pi over 180. Well, we know that 45 goes into 180 4 times. So the answer to this is pi fourths. Okay. Next one here, we have pi thirds. So first I'm going to turn pi thirds into degrees by multiplying by 180 over pi. I know that the pi values cancel and that 3 goes into 180 60 times. So this is 60 degrees. Okay. So I start at my initial side, and this is going to go all the way up until I hit my terminal angle here. So that means this entire shaded region is 60 degrees. And I need to find this region right here that's separating the terminal side from the y-axis right here, so this angle here. Well, I know that this entire side here is 90 degrees. So I can just take 90 minus 60 and I get 30 degrees. Okay? But since my answer was in radians, I need to turn it back into radians. So this is 30 over 1 times pi over 180. Okay? 180 divided by 30 gives me 6. So that means that this is 1, this is 6, so this is equal to pi 6. Okay. Okay, this next part here is talking about a coterminal angle. So a coterminal angle is an angle in standard position that shares a terminal side. To find coterminal angles, we add or subtract 360 degrees. Find one positive and one negative coterminal angle for each of the following. So all we have to do is we take our number, so 137, and add 360, and then do 137 minus 360. Okay, so 137 plus 360 is 497 degrees. And 137 minus 360 is negative 223 degrees. So these are my answers. And I do the same thing for B. So I do 570 plus 360 and 570 minus 360. So 570 plus 360 is 930 degrees. And 570 minus 360 is 210 degrees. These are my answers. And then lastly, part C, negative 630 degrees plus 360 degrees, and then negative 630 degrees minus 360 degrees. So this is going to give me negative 270 degrees. And this one's going to give me negative 990 degrees. Okay. And then we're going to do one more part of the notes. And on your paper, you should have a blank side. We're going to do it on that blank side. Okay. And I want you to label this graphing angles. And the reason why I'm adding this to the notes is because it talks about this on the practice. And I want you guys to be able to have all the information to do the practice. So what I'm going to do is I'm going to go to part A, the coterminal angle, and I'm going to write down the answers that we got. Remember, we got 497 degrees, and then we got negative 223 degrees. Okay. 497 degrees is a positive degree. So when we graph this, we know that we're going to go counterclockwise. Negative 223 degrees is negative, so we know when we graph this, we're going to go clockwise. Okay, and I'm going to explain why right here. Okay, so here's my two coordinate planes. Remember, when we draw coordinate planes, this is 0 degrees, 90, 180, and 270. And then when we label these as quadrants, this is quadrant 1, 2, 3, 4. Notice how we label them. The order is going counterclockwise. So this is the positive order. Okay. So we have 497 degrees. We know that a circle is 360 degrees. So in order to graph this, we know that we're going to at least have one complete circle. So off to the side, I'm going to do 497 minus 360. And so 497 minus 360, this gives me 137, which means I'm going to start right here at my initial point, and I'm going to do a full circle. Okay, that's 360 degrees. Now I need to add another 137 degrees. Well, I'm going to continue this. This is 90. And then somewhere over here is going to be my 137. From here, I'm going to take the point from the origin to the point that I stopped, and I'm going to draw a line. Okay, this is my terminal side of the angle. And that's it. That's how you graph it. Versus the negative one, so let me go ahead and label this one. We are going to go clockwise. So now we're going in the opposite direction. So here is my starting value. Notice that negative 223 degrees is not a perfect circle. So we're not going to have a perfect circle when we graph this. It's going to stop before it forms a circle. Okay, so we're going to start here. We're going clockwise, which means we're going backwards. And we're going to stop somewhere over here because this is 90 degrees. This is 180 degrees. And now this is 223 degrees. And then I'm going to draw my point at my origin and where I stop. And I'm going to draw a line up. And that is my coterminal side. So this is the graph for these two examples.